You are welcome to another biology class today. The topic that we want to look at for now is plasmolysis. Plasmolysis, and is part of our broad topic on osmosis. Now we are going to look at definition of plasmolysis. We are also going to look at the process of plasmolysis. We will also look at effects of plasmolysis. Effects of plasmolysis on plants. Look at the effects of plasmolysis on plants. Then we'll briefly describe experiments to show plasmolysis in spirogyra cell or filament. Then we'll look at conditions that cause plasmolysis, conditions that cause plasmolysis, conditions that cause plasmolysis, and finally we'll quickly look at the opposite of plasmolysis, the reverse, of plasmolysis in plants, which is turgidity. So we're going to look at these, few subtitles under the broad, topic plasmolysis. Now let's go straight to the, topic. Now, plasmolysis is the, shrinkage of the vacuole of plant cell, whereby it pulls, from the cytoplasm, pulls from the wall of the cell. So let's quickly look at the main points of that process. Plasmolysis, as it is the shrinkage of the vacuole. Plasmolysis is the shrinkage of the vacuole and pulling away of the cytoplasmic and pulling away of the cytoplasmic linings, pulling away of the cytoplasmic linings from the cell wall, from the cell wall, when plant cell, plant cell is placed in strong solution, is placed in a strong solution. In other words, you already know the effects of a strong and weak solution on a cell, leading to either endosmosis or exosmosis. Assuming that we have a plant cell, with the cell wall. This is the cell wall, and then we have the vacuole, which is usually large. and the rest part of it signifies the cytoplasm. So here we have the cell wall of plant cell. This is the vacuole, which is usually large in plant cells, and this now represents our cytoplasm. Now, if the plant cell is placed in a strong, solution, the inside of the cell will be less concentrated, will be of lower absolute concentration than the outside that is filled with a strong, solution. So we expect water molecules to move from the inside of cell to outside of cell by exosmosis. Water comes out by exosmosis. So what we are going to have at the end of the day is the pulling away. As this one is reducing, the vacuole is reducing inside because water molecules are moving out. Water molecules are moving out. Water molecules are moving out. Then the cytoplasm will pull away from the cell wall. So what we are going to have is going to be something, like this. Due to the effect of the pulling away of it, we are going to have this one will have reduced because water keeps going out. And then what we are now going to have is a kind of serious reduction. Serious reduction is going to be pulling away. Serious pulling away of the cytoplasm. So the cytoplasm withdraws. So this is now the cytoplasm that is surrounding the cell. It pulls away. So what we are going to have is that the shrinkage will cause, this is the region of pull away. So the cytoplasm will pull away. Now, this is still our cytoplasm that is pulled away. Then this is the space created. And of course, this leads to the shrinkage of the vacuole. So this one is the shrinked vacuole. That's our newly shrinked vacuole. This is illustration of how plasmolysis takes place in a plant cell. Now, when plasmolysis takes place this way in plant cell, it leads to wilting of the plant. It leads to wilting of the plant cell, and the leaves of the plants will wilt away. The tender stem will wilt away, and if that continues for a long time, and water is not supplied to the plant, then the plant will eventually die. Now, it is possible to carry out experiments in plants, particularly using spirogyra cell, to show the effects of plasmolysis in cells. Now, if a spirogyra cell is placed in a strong salt solution, assuming that we have filaments of spirogyra, that way each segment representing a filament. So if this is a filament of spirogyra, that's a filament of spirogyra. Each one represents, assuming that this is our vacuole, This is our vacuole. This is our vacuole. Then this one represents the cell wall. Cell wall. The cell wall. If the spirogyral filament is put in a, if it is put in a salt solution, it means that the surrounding of the cell is concentrated than the inside of the cell. So we expect that exosmosis will take place, and the vacuole of the spirogyra will shrink, pulling away, pulling the cytoplasm away from the cell wall. And if the cells that have been placed in a salt solution, if they are brought on the microscope slide and you observe, you see that the cytoplasm will have shrunk away from the cell wall. You see that it will have shift away from the cell wall. So the next thing that we look at now are the conditions that cause hemolysis, conditions that cause plasmolysis, conditions